audience! Good day! Students, how are you today? Are you ready to listen and to learn more basic mathematics? This is our very first tutorial and educational video in the field of mathematics in junior high school program. In this video, we are talking about the introduction of finding prime numbers, a preparation for your basic mathematics grade 7 and grade 8 lesson in first quarter. Before you watch this video, you can follow and subscribe our YouTube channel of the SMAPI Mathematics Club. If you like to watch educational video on Facebook, you can follow and like SMAPI official page of Math Club at www.smapimathclub. Let us start to listen and learn more mathematics. Today, we will discuss about the introduction of prime numbers. Students, do you have any idea about prime numbers you have already learned during your elementary days? Alright, so let us discuss a definition of prime number. A prime number is a whole number or natural number that is greater than 1 that cannot be made by multiplying other whole numbers. It is a natural number that has exactly two distinct natural number divisors, the number 1 and the given number itself. Meaning to say, a prime number must have only one factor. For example, number 2. So number 2 is one of the examples of the prime number. So we derive that the given prime number 2 is expressed in the given factor forms. So the possible factors of 2 is 1 times 2. Is there any other factors of the given number 2? So there is no other possible factors with that. So the factor form of 2 is only 1 times 2. And we notice that in the given definition of prime numbers, it has only two distinct number divisors, the number 1 and the itself number given is 2. Another example is 3. So the factor form is 1 times 3 and the given number is 5, 1 times 5. We notice that in the given examples, if these natural numbers that has exactly two distinct natural number divisors, the number 1 and the given number itself. That is a prime number. Students, let us talk about the Sieve of Eratosthenes. Who is Eratosthenes? Eratosthenes, he was a great polymath, a mathematician, geographer, poet, astronomer, and music theorist. He was a man of learning, becoming the chief librarian at the Library of Alexandria of Egypt. His work is comparable to what is now known as the study of geography, and he introduced some of the terminologies that was still used today. According to the definition in number theory, the Sieve of Eratosthenes, introduced by the Greek mathematician, that is an efficient method of identifying the prime numbers. This term was introduced in the year 1803. So the Sieve of Eratosthenes is an ancient algorithm or method for finding the all prime numbers up to any given limit. It that is so literally marking as a composite number. So for example, a composite number is not a prime number. The multiples of each prime numbers starting with the first prime number, which is 2. Also, it is a procedure for finding prime numbers that involves the writing down all the odd numbers from 2 up in the succession and crossing out every consecutive prime numbers and so on. With the numbers that are never crossed out, that is being prime. The key distinction from using trial division to sequentially test each candidate number for divisibility by each prime numbers. Okay, students, let us try to find the following prime numbers starting from 1 to 100. Students, now let us find the prime numbers between 1 to 100. So here are the procedures. First, to find all the prime numbers less than or equal to 100, proceed as follows. First, let us generate a list of integers from 1 to 100. So these are the numbers given on the left side. Next, the first number in the given list of first 100 numbers is 2. So the number 2 is the first prime number. Then, cross out every second number in the list after 2 by counting up from the 2 increments of 2. So this will be all the multiples of 2. Meaning to say, these are the even numbers that are which ends with 2, 4, 6, 8, and 0. So cross out all the multiples of 2. So we have 4, 6, 8, 10. And we notice that all of these multiples of 2 which ends at 2, 4, 6, 8, and 0. So cross out all of these numbers. Okay, students, now we have already crossed out all the multiples of 2. The next step to do is, the next number in the given list after 2 is 3. That is the next prime number. Next procedure, cross out every third number in the given list after 3 by counting up from 3 increments of 3. This will be all the multiples of 3 in the given list. So let us count by 3. So we are starting from here, which is 3. So plus 3 will be 6. So 6 is already crossed out. Then 6 added by 3 is also 9. So cross out by 9. 9 plus 3 is 12. So 12 plus 3 is equal to 15. 15 plus 3 is already 18. 18 plus 3 is 21, and so on and so forth. Okay, students, we have already crossed out all the multiples of 3. The next step is we find the next prime number, which is 5. And this follows the procedure. If the given prime number is this, so we should be added by the multiples of 5. So the next number not yet crossed out in the given list after 3 is 5. So cross out the fifth number in the list after 5 is counting up from the increments of 5. So for the example, all the multiples of 5. So we have already crossed out all the multiples of 5. So that is, which is ends with 5 and 0. So we can easily cross out all these digits which ends with 5. So that it is, we have already crossed out all multiples of 5. And the last step to do is, the next prime number after 5 is 7. And cross out all the multiples of 7. So 7 plus 7 is 14, still there. 14 plus 7 is 21. 21 plus 7 is also 28. 28 plus 7 is 35. Plus 7 is 42. Plus 7 is 49. So cross out 49. 49 plus 7 is 56, plus 7 is 63, plus 7 is 70, plus 7 is 77. So cross out 77. 77 plus 7 equals 84. 84 plus 7 is 91. So cross out 91. 91 plus 7 is 98 plus 7 is 105. So that is until 100. So we have already crossed out all the multiples of 7. The remaining here is, that is all the prime numbers. So the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So all the circled numbers are prime numbers. These are the prime numbers between 1 to 100.